So I'm saying that when you do a min-max transformation, the formula for min-max transformation is simply x minus minimum all over maximum minus minimum. Okay, let me delete this and take it again so we can get it clearly. Min-max transformation is done by the formula x. This is our x now. We are working on this course now. X minus the minimum. Okay, the minimum is 31. And this 31 should be what? An absolute reference. All over the maximum. Go to maximum. Minus minimum. Of course, this should also be absolute reference. And you press enter key. Then you copy this down. Okay. So that's how you do your min-max transformation. Okay. You can see the minimum number is 0 and the maximum number is transformed to 1. All other numbers are in between 0 and 1. So for the decimally scaled score, this will reduce the numbers to the range of -1 to +1 within that range. And to do that, that is achieved by dividing this number by 10 to the power of n. And n is chosen such that it will be the number that will drop the answer such that it will not exceed 1. It will not exceed, the absolute value will not exceed 1. Okay? So in this case, that will be what? That will be 10 to the power of what? That will be 10 to the power of 2. Okay? Now, if you look, you will see that the highest number is not up to 1. It's not more than 1. Okay? Now, this n, this power, you have to choose it such that it will be it will be the number that makes the answer closest to 1, as close to 1 as possible. Okay? So, like, for example, in this case now, if I had chosen 1 here, what would have been the result? If I have chosen 1, you see that some numbers would have exceeded 1, isn't it? So it is the highest number that will drop the answer such that it does not exceed 1. That's what you choose for this power here. So by looking at these figures, I could tell that that's that. What you do is you use the highest number among the scores, the highest number. You check it, that highest number, divide it by 10 to the power of something such that it gives you a number that is less than or equals absolute value of 1. The closest, the highest number that will make you achieve that. That's what you use. Understood? Hmm? If you want to get the points more clearly, for example, if you use 1 here, let's try it out and see, so you see what I'm talking about. If we use 1 here now, for instance, you see already we're having some numbers are greater than 1, right? If we use 3, the numbers are too far from 1, too much lower. Even the highest number is too much lower than 1. It could be closer, okay? But if we use 2, that's just right. You see, it's closer to the highest number. Let's look for the highest number. The highest number is 97. Look at it. You see, it's very close to 1. Okay? So all the numbers will be, if you have negative numbers, mixture of negative and positive, all the numbers will range within -1 to +1 when you do a decimally scaled score transformation. Are we still on the same page? Now, when we explained this, I mentioned something. I said, technically, when you do ranking, there's no transformation as such. I don't know if anyone remembers that, technically speaking. It just positions them. It's just a measure of position. It just kind of arranges these scores into their respective positions. That's what ranking does. Okay. Although sometimes in some texts they categorize it as transformation, but the the ranking is not, it doesn't transform data in the sense, in the same way that these other ones transform data. Okay. Why? Because ranking is just a measure of position, and the rank of a number doesn't give an exact, it doesn't exactly correspond to the values. It just measures the position. It doesn't give, um, it doesn't give out accurate representation of the magnitude of these values. It just gives their positions. I don't know if you are getting what I'm saying. For example, see what I mean. If you look here now, the person that takes first is 97, right? Second is what?
96.
96. If you look at their rank, what's the difference between their ranks?
It's 1.
1. But if you come here, let's come here. You see, let me see. Let's use this one. Oh, all of them are just so uh, just a minute. Okay, let's use this now. Let's use this one. Okay, now, what's the difference between the scores here? You see, this guy got 6. Here, the score difference is 1. The rank difference is 1. Here, the score difference is what?
2.
2. What's the rank difference?
3.
3. Can you see it doesn't correspond? Here, a score difference of 1 is giving a rank difference of 1. Then how come a score difference of 2 is giving a rank difference of 3? If you even go and check others, you see it will give something else entirely. Okay, the numbers are so close to themselves, so let's look for one that will make it clearer. Okay, look at this one now. Here, the score difference is 1. Okay, 1, 1. The numbers are so close together. That's why we're having it like this. Okay, look at this one. Here, the score difference is what? 2, but the rank difference is 1. Huh? And we had a situation before where score difference was 2 and rank difference was 3. Remember that?
Yes.
So you see, it doesn't correspond. Why? It's just a measure of position. It's not a direct value transformation. It doesn't absolutely transform the values. But these are real transformations. These ones, they are real transformations.
So can I ask a question?
Please do.
Okay, what
I can't hear your question, please. Please ask the
Yes,
question.
sir.
Please ask the question again so it can flow, can be recorded.
okay, sir. I'm asking the importance of min-max and decimally scale in
And
data transformation. Like, what will it help you
to
to achieve?
achieve,
What's the
yes. Even
sense of it?
these calls, they all help you to achieve basically the same thing. Okay?
Okay.
Can anybody try to explain that? Anybody have an idea of that?
I think he helped to rank scores,
To
like rank
achieve,
scores in hierarchy.
to achieve what?
To achieve, I think, to enable to make decisions, like you have a first, second, third, like that, in order to make a certain decision
That
about the data.
okay, that's what
Or
ranking. That's what ranking does. What you just explained now is ranking. That's a correct explanation of ranking.
Okay.
But these three, yeah, thanks for that attempt. Now, these three, they are used for transforming data so as to streamline the data. If you look at this data, like I told you before, I said even if these numbers were much larger, the ranks will still be small, the transform data will still be small like this. Okay? They will still be small. They will still be, min-max will still be between 0 and 1, even if here you are dealing with millions, hundreds of millions, whatever the values. Same with decimal scores. So you can see that this transformation, they help to streamline data, to reduce the range, to reduce it to smaller numbers, which can easily be used for computational purposes. Okay, so there are statistical models that require that you transform data before they can work properly. You understand? There are some models, for example, there are classification models that for you to use the model, your data must be transformed maybe to something like min-max or z-score transformation. Otherwise, you won't get accurate results. Is the question answered? Is it clear?
Yeah, to me it is clear.
Okay.
Understood, sir.
I think Stewart asked the question. Is it clear?
Yes, sir, it's clear.
Okay. So it's a requirement in some data analytics processes. It's a requirement. That's why it's an important topic in data analytics. Very, very, very important. In fact, data transformation is part of the data preparation process. In other data preparation, we do things like data cleaning, we do data validation, data transformation. It's part of the preparation process. You know, the data analytics processes, we have a capturing of data, preparation of data, analysis, pre-processing or exploration, analysis, and interpretation. Now, what we are doing now is part of data preparation. It's one of the things that is done during data preparation. So we are not just doing Excel. This is not just mere Excel. This is real data analytics. This is data preparation. Are we okay?
Yes, sir. So it's
Oh.
just preparation of data, like it's not interpretation yet.
No. This is preparation of data, not interpretation.
Okay.
There's nothing in interpretation now. Interpretation is a small, but it's just that you have to now learn other things first before. Interpretation doesn't take time to learn. It is the build-up that takes the time, data preparation, especially data preparation. Data capture, data preparation takes time. Then exploration, analysis. Interpretation is just to interpret the results. Okay? Just to interpret results. And when you are talking of analysis, is not every data, not every data data analysis or analytics process that needs technical interpretation. There are some that are quite simple that you don't need to, do much. Even a layman can interpret some. Okay? Even a layman can interpret some of those things. For example, if you do you do a chart like this, for example, like this one, for instance. Even a layman can interpret these ones. You don't need special interpretation here. By the time you do a job like this and it's submitted to the stakeholders, they can easily see what's going on. Okay? They can easily see what's going on. Like here, they can see that among those that got A's, the hardware, people with hardware major, there are more than those in networking major, just like that. You can see that it's only those with networking major that failed. So the data analyst does not need to be called in to interpret this one. Okay? Is it clear?
Yes.
But when we talk of data interpretation, as a special process. We are talking about things that are more technical. That's when you are, after doing hypothesis testing. We are talking about interpretation of the result of hypothesis testing. That's where we talk about special interpretation of data. That's what we talk about, interpretation of data as a special process. Exactly.
Yes, sir.
We'll get there. You see, these things, the truth is that this course, when you take it step by step and you are really grounded, if we take it step by step, it's more beneficial, very beneficial, so that you really have a foundation. You have a strong foundation. You cannot be pushed here and there. You are stable. You can face challenges on the job and all that. Okay, now let's look at the discourse transformation. So maybe we should reiterate here. Ranking, just a direct measure of position, which is used to assign positions to values in the data set, from highest to lowest or lowest position to highest. Mean mass transformation reduces the number to between what and what? Between what figure and what figure? What number and what number?
0 and 1.
Yes, between 0 and 1. That's what your mean mass transformation does. Okay, reduces numbers to between 0 and 1. What about decimally scaled scores? What does it do? Decimally scaled will reduce numbers to between -1 to +1.
-1.
Yes, to +1. If there are negative numbers, that's where you have minus. But if there are no negative numbers, of course, there will be nothing like minus. So it will be between 0 and 1. Okay. So you can see that these transformations, what they do essentially is that they reduce the numbers to become smaller numbers, so that when they are being used for computation, it will be easy. You may not realize that that's a very big advantage. That will have a lot of benefits. Why we not realize that is because we are dealing with small data here. Okay. When we are talking of data sets that contains thousands upon thousands upon thousands, working with large numbers will create a lot of drawbacks. It will be slow. It will be a difficult process for the model and the computer. Okay, so it will be slower. But when the numbers are small like this, it's easier to handle the data. All right, so how do we compute z-score? How do we do z-score transformation? We are going to first of all, we are going to compute the mean. You can give us formula for mean. How do we get the mean? Let's do a quick process here. I can just edit this one and then change this to average. Okay, so that's the mean, right? We need to use it for this called transformation. For this called transformation, is equals x, which is the number, minus the mean. All over what? Over what? Oh, sorry, there's something that we have not computed. That we need. What is that? What have we not computed that we will need?
It's standard deviation.
Yes. Standard deviation equals stdev sample. Once again, let's copy this. In Excel, we have to work smart. Are they giving a different figure here? Oh. You see what it's doing? This figure is actually wrong. It's using relative reference, so it's to 101. This is B4 to 101. B4 101. B4 101. This is what happens when you are using relative reference. So it just be changing the figures for you. B4 101. Okay, so now we have our standard deviation. Oh. We don't have our standard deviation. So we have to do stdev dot s. That's our standard deviation. So we are going to use it to compute the z-scores. Z-score is x minus the mean when we do z-score, what value range are you expecting? Minus the mean divided by what? Standard deviation. What range of value are you expecting? I told you in the last class that z-scores is based on the normal distribution, okay? And we've seen the standard normal distribution that most of the numbers lie within -3 to +3. So we don't expect anything. Who can tell me why is this giving error now? Why?
Absolute reference.
Yes. Absolute reference. Okay, so you see, as an analyst, when you are working with numbers, figures, right? When you are working with data, when you really understand the subject matter, if you are getting unusual results, you will know. Okay? For example, you are doing transformation like this, you already know the range of data to expect. So if, for example, I'm getting something like 10, 20, 50, 100 here, I'll know there's something wrong somewhere. Understand? So that's why it's good to learn the theories, the principles. Okay, that's why last week we started by looking at all these formulas. Okay, what I will do now, I will show the slides that shows all these formulas. So we just look at them again. Okay, so we'll see what I'm talking about. Just give me a few seconds.